Hi, I'm Mariano Guerra, and this is outlining a UI for Tremor. You can find the slides in this URL. You can just go to marianoguerra.github.io and go to the talk section, and you can find the slides there. And if you want to follow me on Twitter, I'm Mariano Guerra. So a little bit more about me to understand the background of what I'm saying. I'm a Tremor user. We are running Tremor in production in multiple systems. We are not using it in the standard expected way, I guess, but we plan to use it in the standard expected way in the future. I also belong to a community called Future of Coding, which is a community of people that like to think, talk, and build prototypes about the future of programming. This influences a little bit this talk. I'm the co-founder of InstaDeck, a no-code data analysis and visualization tool, and I'm working right now on a new product called Glue Data, which is a no-code tool for data integration. Disclaimer, I have not shared these ideas yet with the Tremor developers, so they may be as surprised as you. And I'm aware that there are some features that I will mention that are already available, and there may be more that I'm not aware. So I will try to highlight the ones that are already available and I know about. So why a UI for Tremor? I think there should be 3 UIs at least, because I think there are 3 different use cases at least. One is monitoring Tremor itself. You're running Tremor in production. You want to see if everything is running okay, if Tremor is running okay, resource usage, if the pipelines are behaving, and some metrics for pipelines. The other one is troubleshooting. Something is going wrong. You have to figure out why and try to find a solution. And the third is developing, creating a new pipeline, making changes, seeing how it behaves until you are sure you can deploy to production. So let's explore some ideas on how to create UIs for this. Of course, there's a general approach or design, which is create a web application that talks to Tremor and displays a table of all the running pipelines and the status, some metrics. You can click on a pipeline and see the metrics for the pipeline. That could be a thing, but what I'm proposing here is to think a little bit outside the box and see if, look around for some inspiration for different ideas. So Tremor is an open source project. That means it has a community of people that use Tremor in different ways. They have different skills, and Tremor wants to foster collaboration in the community. But as any open source project, resources are limited, and the skills of the developers and or people that can contribute are different and may not intersect with the skills required to build a traditional UI in the traditional sense. So how could we design one or more or no UIs that take into account this? I'm taking some inspiration on a book called Tools for Conviviality. I will quote some parts of this tool and a related paper that I link in the last slide. So a convivial tool gives each user the greatest opportunity to enrich the environment with the fruits of his or her vision. This book is not about software, it's about tools in general, so the quotes may sound a little bit general or generic. Convivial tools encourage users to be actively engaged and to generate creative extensions to the artifacts given to them. So still general, but you may get a sense of where I'm going. If you ground it in a piece of software that I think is convivial, like Emacs, even when I'm a BI user myself, but Emacs encourages users to be actively engaged and generate creative extensions to Emacs itself. So I think creating something like this is an interesting approach. And the goal of making tools modifiable by the user does not imply transferring the responsibility of good tool design to the user. Like keeping with the Emacs example, like Emacs is a thing that was created and designed, and it has some predefined behavior. So you can download Emacs and use the defaults, and it's already a good tool, but it allows you to extend it to solve your particular needs. Convivial tools will remove from the maintainer the impossible task of anticipating all possible uses of a tool and all people's needs. Again, this is not that Tremor exposes some API and call it a day. It's more like the Emacs way, where the maintainer knew that they, or the maintainers know that they cannot create a default text editor that solves all problems for all users. So they create kind of a platform, and let the end users fill the gaps or the niches. I think this also is an interesting idea. And if we had to classify systems in this spectrum of conviviality, on one side we will have general purpose programming languages, which are powerful but hard to learn and often too far away from conceptual structure of the problem. That's a hard one to read, and takes too long to get the task done or problem solved. So on this side of the spectrum, we don't have Tremor. Think on this side of the spectrum as Rust, which is a general purpose programming language, but it has these properties. Particularly, it's too far away from the conceptual structure of the problem of creating pipelines for stream processing. That's why Tremor exists. So it's not on the extreme side of the spectrum. And it makes it easier to operate on the domain with concepts about pipelines and stream processing. So it's a step better than a general purpose programming language. So a quote for this side of the spectrum is, "We were the Turing Tarpit in which everything is possible, but nothing of interest is easy." On the other side of the spectrum, we have turnkey systems, which are easy to use. No special training is required, but can't be modified by the user. And this means that you take it or leave it. If we create a UI for Tremor that has a set of features, if those features solve your problem, then great. You don't need to learn a lot. You just click around and get what you need. But if the UI doesn't solve your problem, you cannot change it, because like the way we build UIs right now means that if you wanted to change it, you had to know like the JavaScript and the framework we are using, and you will have to go to GitHub, clone it, set the local environment, get it up and running, make the changes. But now you are not using the UI from Tremor, you are using a fork. So now you have to maintain your fork and keep it up to date or try to merge it back. So I think it's not good enough. On this side, beware the over-specialized system where operations are easy but little of interest is possible. So to create a UI that provides something else or something than Tremor, like right now you can get Tremor running, you have the CLI, you have the API, you can get Visual Studio Code running and the language server, and you have a nice environment to use Tremor. So if we are going to create something on top or something on the side of Tremor, it has to provide something else. And I think that thing that it has to provide is a live system. So I will describe some properties of a live system from liveprog.org. Live programming systems give the programmer immediate feedback on the output of a program as it is being edited, replacing the edit, compile, debug cycle with a fluid programming experience. So the idea is that you have kind of a REPL experience. If you ever used a REPL, you know what I mean. It's you feel like you are in the system and you are manipulating the system and getting feedback instantly on your changes, and that allows you to have a tighter feedback loop and develop in that way, and not like have some text files and change them and save them and deploy and see the outputs and then do the cycle again. Structural programming environments understand and preserve that structure. So you are not operating, allow operations at the level of the structure rather than at the level of text. You are not, like, the thing you are manipulated is not characters in a text file, but some higher level structure that is closer to the domain, which is in this case pipelines. It's tangible. In the traditional view of programs, execution takes place behind the scenes and leaves little record of what happened. And this, at least in future of coding, is we call it playing computer in your head. You're editing a text file, and if you want to think about what's going on, you have to know the semantics of the machine or the language and run it in your head to have a dynamic view of what's going on with the text. We are interested in programming systems that make execution transparent, tangible, and explorable. And concrete. People find it easier to start with concrete examples and generalize afterwards. So another way of viewing this, or an approach to design to create a UI for Tremor, one or more, or none, we will see later why none, is from this article on designing for emergence, and the link is at the end of the slides. Uh, this person classifies design in a quadrant with two axes. One, the vertical assumes designer has no knowledge, two, the assume user has knowledge, and horizontal, designer has control or user has control. On the bottom left, we have high modern design. And if you're interested in this, you can read the book Seeing Like a State, which I have, but I cannot find. If you're interested in user-centered design on the top left, you can read this book, The Design of Everyday Things. I hope you can see that. And if you are interested in design for emergence, I don't know if there's a book of design for emergence, but there are books about emergence. You can check them. And on the bottom right, basically, you uh, you basically do whatever you want with whatever the designer did, which is many times what happens in software. So the idea is to design something for emergence. The idea is like user-centered design tries to do some like Pareto design in the sense it tries to see what users are doing or need and grab like the 20% that solves the 80% of the problems and solves that. And if you find yourself in the tail, then bad luck. And so the idea is to design for the long tail, and design for the long tail, not in the sense of trying to create something that will solve all problems for everybody, but what this paper about convivial tools talks about is give a design toolkit, which is a set of components that people can use to solve their problems by composing them in different ways and extending them. So going back to the use cases of the UIs, the first one I mentioned is like system level monitoring. There's something already available on Tremor for this. You can do Tremor in Tremor, which is there are sources that will expose Tremor metrics. And since Tremor is good at like processing metrics and sending them to systems that can display them, I think we shouldn't focus on this because there are already solutions for this, and Tremor is good at that. And people using Tremor already know those tools. So maybe having like a default setup or a recommended setup for monitoring Tremor in Tremor. The second use case is troubleshooting. And here we can take inspiration on Erlang's Observer. Erlang is a programming language and a virtual machine that provides a tool called Observer, which we can see here. And this tool allows you to inspect the current runtime status of the Erlang virtual machine, see the processes, the relationships. You can drill down into each actor state, and you can even manipulate actors, like even you can kill them and see how the system behaves. Another place where we can take inspiration is on eBPF or dtrace style dynamic prose. These are two domain-specific languages, one for Linux and the other one for Solaris, that allow users to create small scripts that are dynamically injected into the running system, the kernel. And these DSLs can be verified that they are not going to affect performance or they are secure, and allows the user to extract runtime information to userland and make sense of what's going on. I think it will be interesting to have some kind of dynamic probe into Tremor. That can be programmed in a subset of Tremor script even. I don't think, because like Tremor script kind of solves the problem of getting some input data and doing some manipulation on it and sending it somewhere else. That somewhere else may be like a WebSocket where the UI is listening to the updates. And for the use case of developing, if we want to promote like a REPL environment, I think there are two ways of doing it. One is doing like libtremor, which is exposing the core Tremor as a library, and you can create like lightweight instances in memory and feed them pipeline definitions and like mocking the inputs and the outputs and getting them so you can display them in a live environment. The other one is having something like transient pipelines, where you can open a connection, send the definition of a pipeline, and it will run in memory and feed you back the outputs until you like close that connection, and then that pipeline goes away. Any of these two will work, I guess, or any other. But the idea is to promote this idea of REPL style development, where you are like running small snippets and seeing what happens, and like refining them and always inspecting the output live as it happens. Another idea is record sample traces, which a tool called Darklang, which I will have a link later. It's a tool that allows you to create basically HTTP handlers in a structured editor. But if you make an HTTP request to an endpoint that doesn't exist or one that exists, like Darklang will record those traces, so you can develop against real traces and keep those examples at hand to inspect the content, but also to like run your code against real traces of the system. And again, like eBPF and trace style probes here, together with this REPL environment, where you can say, okay, I want to run this, and I want to capture like the thing that goes between those steps, and I want to capture the value of this here. It will like send you back those values for inspection. So I've been talking about UIs, but I haven't talked about like a graphical user interface yet. And it's because I believe there probably should not be one or none in sense. There shouldn't be one from scratch. I think we can stand on the shoulders of giants and split the problem in two, create a headless UI that exposes all of these ideas I've mentioned, or some of them. Or other way of seeing it is like a Tremor tool server, taking inspiration from the language server protocol, which is splitting the behavior of an IDE in two, like the visual tool you use to edit your code, and a service that exposes information about the languages and compilers for different languages. That means that different IDEs can reuse the same language servers because they talk the same protocol. I think if a Tremor exposed like a Tremor server, tool server, then we can experiment with multiple way of doing UIs on top of it and seeing what emerges out of it. Some ideas. There's a tool called Glamorous Toolkit, which promotes an idea called modal development. It's an environment for Smalltalk. And this is common in the Smalltalk community, which basically you live in an environment where everything is programmed in Smalltalk, and you mold your environment to solve the problems you have. You never create like finished packaged applications. You just have like an environment full of components that you can plug together and reuse and share. And here we have Glamorous Toolkit with two components that allow the user to inspect the state of Jenkins. So now you have a UI for Jenkins that looks much nicer than the default I've seen. And you can even share these components, bring others, reuse components that may not have been created initially for Jenkins itself, and extend them to your needs. So if Tremor exposed this Tremor tool server, we could use Glamorous Toolkit to reuse many of these components and to create a UI for it. If you are more into Elixir, Erlang, or notebooks, there's a project called Livebook, interactive and collaborative code notebooks in Elixir. It's a notebook style. The cool thing about the Erlang and Elixir is that it plays really well with like streaming and like WebSockets and live systems. And the Livebook project is really nice and looks really nice. It's really nice to develop on. It has even collaboration. And the idea here is that you will have your Livebooks for Tremor, and you will use a library that exposes the Tremor capabilities, and share components and share Livebooks with the community and build on top of others. Basically, here you can think about Emacs. That you even use Emacs for this. And if you are more into command line applications, and there's an interesting project called NuShell, which the tagline is a new type of shell. And the idea of Nushal is that it doesn't operate on stream of bytes. It operates on tables, even they can nest. And second, it understands more advanced data types like sizes and dates and stuff like that. And the language of Nushell is much modern, much nicer than traditional shell script languages. So here, for example, I'm getting a list of the files in the current directory as a table, and I'm filtering it where the size is more than 10 megabytes, so it understands units, and then it's sorting it by modified because it understands dates. Um, and the interesting thing here that is shared with all the others is that like the Tremor developers don't have to expose APIs or ways of doing filtering and sorting because tools like Nushell and Elixir and Smalltalk can easily do the filtering and the sorting on the other side. So it also reduces the amount of things that the Tremor side has to expose because the other side is kind of smart and powerful. Here we see that we are fetching some JSON and getting a field, and it understands nested data. So this is kind of a JSON object. We could also think of low code, no code front end for Tremor. The obvious one would be to create a node and wire front end for Tremor. I've done them and I have my reservations, but if you want to see a really cool one, go to enso.org. They are doing something really interesting there. The other one is some kind of block editor like Scratch or a structure editor. You can check Darklang and Hazel for some really interesting takes on that. But I'm here to propose another approach that I've been developing in the last couple of months. And it's an outline abstraction for configuring complex tools and interactively developing them. So this is the glue data. The core abstraction of glue data is a playbook, which is kind of a pipeline or a workflow, different names for the same thing. It has a trigger, which one or more triggers, which is when does it run. By default, it has a schedule trigger that will trigger every minute, but you can you can configure advanced schedule expressions by adding one or more of the available children for the schedule node type. You can even add tags and nodes for your own organization. And it has 0 or more steps. So I will add one step. And again, it will list to me the type of children that steps can have. So I can have conditions, HTTP requests, and to Slack message. Right now, Glue Data is a tool to integrate internal systems and APIs and databases to chat messaging applications. So those are the available node types right now, but the idea is to extend it. And if Tremor exposes this tool server, I can integrate Tremor with it. And so I will create an HTTP request and I will try to send it to Slack. So now I created a HTTP request, and all nodes usually are created with default values. In this case, it's fetching some missions from SpaceX. And it opened the dialog so I can customize like the request method, the URL. I can build the URL by parts, customize the headers, the response, and again, tags and nodes. I will leave the default because it's okay for this demo. But I can instantly go and run the HTTP request. And it will run, and it will tell me it started and it finished, and the status is 200. I can inspect the output, which is a JSON with some mission information. I can inspect the headers. I can inspect the metrics of the request. And the second step is send Slack message, and it also has some defaults, and I can see the preview of how the message will look like on the right. And as I wanted to put it on the other side. As I modify the configuration, I can instantly see the changes on the right. So I will try to run this, and it will run, and it will tell me that invalid auth there. I can inspect this in more detail in the output and in the headers, but it's enough to see the run logs. So this is because I have to put my own key there. So if I run it again, it will say channel not found because the channel ID is not one I have. So I will put general here and I will run it. And you may hear the message is here with all my header in the wrong way. And so now I have my Slack message, which is fixed. I want to use some information from the HTTP request. So I will go again to the output. And let's say I want to send the mission name somewhere. So I will click here and I would give it a name, like mission. So now we have an output, a custom output called mission that will do a query. It will go to the JSON body, to the first item, and to the field JSON name. And if I run it again, I can see that now it has a value. And if I like change the index, it will do the second one, which is Telstar. So now I have one field I may want to use. And let's say I want to replace the header with that field. So I will click here and I will give this a name. Let's call it header. And now, like if I run it from here, it will run with the default value it has. So I want to bind the output of the HTTP request to the input here in Slack message. So I will click here in the plug, and this will list all the inputs from the step below. There's only one, so I will select that one. And then it will select all the outputs from all the other steps that are compatible with the header, which is a string. In this case, it's only mission. So I will select that one. And now if I run this, it will run individually and will, since header is not set, it will send the default header. And if I run this, it will only run this. So now I have to run the complete playbook to exercise this. And I will run it. And the message was sent. And you can see that now the header is Telstar, which is the second value of the second launch. So now it will be running every minute. And you may hear in the background in a minute or less that a message is sent. So the idea is that if Tremor exposed ways to like create these individual steps and to run and deploy and like get back the individual steps state and the pipeline completely, you could iteratively and interactively and without writing code explore all the capabilities of the tool and um, and bring like lower the barrier of entry to Tremor to people that may not know how to code or may not want to know how to code or may know how to code like me, but when you're getting started, there are so many concepts you have to learn that you may want to explore it in a tool like this. And once you are happy with something like this, you deploy it and it runs even when your browser is not open. So it, and then later you can monitor it with your usual monitoring tools and troubleshoot it, as I mentioned before. So this is an outline of and a proposal for UIs for Tremor. And again, it's all ideas I'm sharing. I don't know if the Tremor developers agree or not with it, but these are some ideas. And here is a list of some of the resources I mentioned in this talk. Bye.